we have this idea of U substitution. So we're going to take a difficult antiderivative, which involves a product, and we're going to use substitution to change this difficult antiderivative into a much easier antiderivative, which is going to involve a different variable. And once we take this easier antiderivative, then we'll just sub the difficult part back out, or back in rather, I should say. All right, so let's take a look at this. The first thing that we're going to do, the steps that you see on your notes and the steps that you see up here on the board, we have to identify our inner function. Now I've rewritten our problem ever so slightly. We know that when we're placing a trig function to an exponent, that the exponent can go after the third letter in the abbreviation or outside of parentheses. So I've written it as sine of x wrapped in parentheses and then squared. Okay, so first things first, what's the inner function? Well, we can see here we have a sine x that is inside parentheses. Let's make u equal to that. We're going to set u equal to the inner function. So over here on the side, I'm going to have u equals sine x. Okay. Now that I have this, by substitution, all right, this becomes u squared. Okay. But the issue is we still have cosine x and our differential dx are both in terms of x. We don't want cross variables. We want one single variable. U can come into play, but only if those x terms are no longer involved. Okay? We need a differential that involves u. So we're going to derive u with respect to x. When we do that, all right, the derivative of u will be du dx. Okay? And what is the derivative of sine x? Yeah, it's cosine x. So we have cosine x right here. Right. The problem is we still have u's and x's on the same side of the equation. So by multiplication, we're going to move this dx over to the other side. So du is equal to cosine x dx. Okay? So step 2 is to determine du. In general, you're going to go right from the first line there to the third line. All right? Automatically throw the du on the left side and the dx on the right side. Okay, we're going to keep them separate. Okay, so basically, u can come into the integrand, but it needs du. So it's a package deal. Du has to come with it. Okay, du can only come in if this can sub out. And coincidentally, we have cosine x dx. All right, so think of this like a basketball game. All right, cosine x dx is going to sub out. Du is the same thing as cosine x dx, so du is going to sub in. So we have u squared du. We've rewritten our extensive integrand with lots of x's and products and everything, and we've turned it into a nice simple antiderivative, u squared du. It doesn't matter what the independent variable is, whether it's x or u or q, doesn't matter. Okay, we just need some variable. Now u is the common one that's used. So that's what we have here, u substitution. All right, so now that we've done our substitution, there's a blank there for step 4. I'll talk about that in a future example. Step 5, antiderive. So let's do it. What's the antiderivative of u squared? Well, it's going to be u cubed over 3 plus c. Okay, so we've done our antiderivative. And that was an easy antiderivative to take care of. Much easier than trying to figure that out. Okay. Now, step 6, we're going to sub our x term back in for u. Right? So u's right here, but u is equal to the sine of x. So we're going to sub the sine of x back in. So we have the sine of x being cubed over 3 plus c. And that plus c is also our final step there. We just got to make sure we have that arbitrary constant. It may be equal to 0, it may not be, so we got to double check and have it there. Okay. Now keep in mind that whenever you do these antiderivatives, you can always check your work by deriving your answer. So if this is what we were given and we take the derivative of that, right? So let's do that. Let's take the derivative of, let's write this a little bit differently, because if we're dividing by 3, it's the same thing as multiplying by a third. So we have 1/3, and then we have the sine of x being cubed plus c. We want to take the derivative of this. Okay, well, that means 1/3 is a coefficient, so it comes out front. And then we have sine of x being cubed. So 3 comes down. We subtract 1 from the exponent, so it's now sine of x squared. right? And then we take the derivative of the inside. So again, remember, this 3 could be here, or it could be there, right? So we have the sine of, or rather the sine of x squared, like so, and we're going to multiply this by the derivative of the inner function. And the derivative of sine is cosine. The derivative of the constant will always be 0. So we have 1/3 times 3 times sine squared x times cosine x. But the 3's eliminate each other, so we just have sine squared x times cosine x, which is exactly what we began with way back there in green. So by deriving our answer, we check and we see that it's correct. Okay, so these are the steps that we're going to use for the examples on the other side of the notes.